The National Electrical Code, or NEC, Section 422.16b of the 2002 edition addresses the connection of appliances. It specifically states that appliances shall be connected to permanently installed wiring systems in accordance with their nameplate ratings and the provisions outlined in that chapter. An installation where a furnace is connected to a generator using a cord and plug is not compliant with this NEC requirement. The furnace, being an appliance, necessitates connection to a permanently installed wiring system. The practice of using a cord and plug to connect a furnace to a portable generator is explicitly not permitted by code. There are several reasons for this requirement. Firstly, safety. A cord and plug connection lacks the security of a permanent wiring system. The cord can be easily disconnected, potentially leading to a shock or fire hazard. Secondly, reliability. A permanent wiring system offers a more reliable power connection. It is less prone to being tripped or disconnected, especially during an emergency situation when the furnace is needed most. Thirdly, code compliance. The NEC serves as a safety standard establishing the minimum requirements for electrical installations. Adhering to the NEC is crucial to ensuring both safety and code compliance. The recommended solution involves installing a permanently installed transfer switch. This device enables a safe connection between the furnace and a generator when utility power is unavailable. Transfer switches are designed to meet NEC requirements and provide a reliable power source for essential appliances like furnaces during emergencies. Let's delve into the specifics of the NEC Section 422.16b. This section emphasizes the necessity of a permanent wiring connection for appliances. The term permanently installed wiring system implies a hardwired connection to the building's electrical system. This typically involves running conduit or cable, such as type NMB or THHN conductors in conduit, from the electrical panel to a junction box near the appliance, and then making a direct connection to the appliance's wiring. A cord and plug connection, by its very nature, is not considered a permanent wiring system. It is a temporary connection method designed for portable appliances that may be moved or disconnected frequently. Connecting a furnace, which is a stationary appliance, to a generator using a cord and plug introduces potential hazards. The cord could be damaged, creating a shock or fire risk. A connection could become loose or disconnected, interrupting the power supply to the furnace. Also, the use of extension cords can lead to voltage drop, potentially damaging the furnace motor or controls. A permanent wiring system, on the other hand, provides a secure and reliable connection. The conductors are protected by conduit or cable, reducing the risk of damage. The connection is made inside a junction box, preventing accidental disconnection. Furthermore, the wiring is sized appropriately to handle the furnace's electrical load, minimizing voltage drop. The use of a transfer switch is the recommended solution for powering a furnace with a generator during a power outage. A transfer switch is an electrical device that allows you to safely switch between utility power and generator power. It prevents backfeeding, which is the dangerous situation where generator power is sent back into the utility grid. Backfeeding can electrocute utility workers and damage electrical equipment. There are two main types of transfer switches: manual and automatic. A manual transfer switch requires you to manually switch between utility power and generator power. When utility power is lost, you must first turn off the main breaker to the house. Then, you start the generator and switch the transfer switch to the generator position. An automatic transfer switch automatically switches between utility power and generator power. When utility power is lost, the transfer switch automatically starts the generator and switches to the generator position. When utility power is restored, the transfer switch automatically switches back to utility power and shuts off the generator. Transfer switches are rated for specific amperages and voltages. It is important to choose a transfer switch that is rated for the furnace's electrical load. The transfer switch should also be installed by a qualified electrician to ensure that it is installed properly and safely. In addition to safety and reliability, using a transfer switch also ensures code compliance. The NEC requires that generators be connected to the electrical system through a transfer switch. This requirement is intended to prevent backfeeding and ensure the safety of electrical workers. Failing to comply with the NEC can result in fines and other penalties. Firstly, consider the capacity of the generator. The generator must be sized appropriately to handle the furnace's electrical load, as well as any other essential appliances that you plan to power during a power outage. Consult the furnace's nameplate to determine its power requirements. Secondly, decide whether you need a manual or automatic transfer switch. An automatic transfer switch is more convenient, but it is also more expensive. A manual transfer switch is less expensive, but it requires you to manually switch between utility power and generator power. Thirdly, hire a qualified electrician to install the transfer switch. The installation of a transfer switch is a complex electrical task that should only be performed by a qualified electrician. They will ensure that the transfer switch is installed properly and safely, and that it complies with all applicable codes. Let's discuss the types of wiring methods that are permitted for connecting a furnace to a permanently installed wiring system according to the NEC. Firstly, rigid metal conduit, or RMC, provides the highest level of protection for conductors. It is suitable for both indoor and outdoor installations and is resistant to physical damage. Secondly, intermediate metal conduit, or IMC, is similar to RMC but is lighter in weight. It is also suitable for both indoor and outdoor installations. Thirdly, electrical metallic tubing, or IMT, is a thin-walled conduit that is suitable for indoor installations. It is less expensive than RMC or IMC but provides less protection. Fourthly, flexible metal conduit, or FMC, is a flexible conduit that is suitable for connecting to motors or other equipment that may vibrate. Fifthly, non-metallic sheet cable, or NMB cable, is a common type of cable used for residential wiring. It is suitable for dry indoor locations only. When selecting a wiring method, it is important to consider the environment in which the wiring will be installed. For example, if the wiring will be exposed to moisture or physical damage, RMC or IMC would be the best choice. If the wiring will be installed in a dry indoor location, NMB cable may be acceptable. In addition to the wiring method, it is also important to select the correct size conductors for the furnace's electrical load. The conductor size must be large enough to carry the current without overheating. The NEC provides tables that specify the ampacity of different conductor sizes. These tables take into account the type of conductor, the insulation temperature rating, and the ambient temperature. It is important to consult these tables when selecting conductor sizes to ensure that the wiring is safe and compliant. Let's talk about overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. When an overcurrent occurs, the overcurrent protection device will trip or blow, interrupting the flow of current and preventing damage to the wiring and equipment. The NEC requires that all electrical circuits be protected by overcurrent protection devices. The size of the overcurrent protection device must be matched to the ampacity of the conductors it is protecting. If the overcurrent protection device is too large, it will not trip or blow in the event of an overcurrent, and the wiring and equipment could be damaged. If the overcurrent protection device is too small, it will trip or blow unnecessarily, interrupting the power supply. It is important to consult the NEC when selecting overcurrent protection devices to ensure that they are the correct size and type for the application. When installing a transfer switch, it is important to follow the manufacturer's instructions and all applicable codes. The transfer switch must be properly grounded to prevent electrical shock. The wiring must be sized correctly to handle the furnace's electrical load. The transfer switch must be installed in a location that is accessible and well ventilated. If you are not comfortable performing electrical work, it is best to hire a qualified electrician to install the transfer switch. They will ensure that the installation is safe and compliant with all applicable codes. In summary, connecting a furnace to a generator with a cord and plug is a violation of the NEC. A transfer switch is the recommended solution for powering a furnace with a generator during a power outage. A transfer switch provides a safe and reliable power source for essential appliances and ensures code compliance. When installing a transfer switch, it is important to follow the manufacturer's instructions and all applicable codes. It is also very important to consult with a qualified electrician to ensure safety and compliance with electrical standards for any electrical installation. This professional can help determine the correct size and type of transfer switch for the application, as well as ensure that the installation is performed safely and correctly. Additionally, a qualified electrician can assist with selecting the appropriate wiring methods and overcurrent protection devices to meet the specific requirements of the furnace and the electrical system. Furthermore, engaging a professional electrician ensures that the installation complies with all local and national electrical codes, reducing the risk of potential hazards and ensuring the long-term safety and reliability of the electrical system. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including the proper methods for connecting appliances and generators. It is essential to adhere to these guidelines to minimize the risk of electrical shock, fire, and other hazards. A qualified electrician is well versed in the NEC requirements and can ensure that all electrical work is performed in accordance with these standards. Moreover, a professional electrician can provide valuable insights and recommendations based on their experience and knowledge of electrical systems. They can assess the specific needs of the installation and recommend the most appropriate solutions to ensure safety, reliability, and code compliance. In conclusion, while it may seem convenient to connect a furnace to a generator using a cord and plug, this method is not only a violation of the NEC but also poses significant safety risks. Investing in a properly installed transfer switch is a worthwhile investment. It provides peace of mind and ensures the safe and reliable operation of essential appliances during a power outage. Always prioritize safety and code compliance when performing electrical work and seek the assistance of a qualified electrician when needed. Let's elaborate further on the potential dangers associated with using a cord and plug connection for a furnace. Firstly, the gauge of the extension cord may not be adequate to handle the furnace's electrical load. Using an undersized extension cord can cause it to overheat, potentially leading to a fire. Secondly, the extension cord may be damaged or worn, creating a shock hazard. Thirdly, the connection between the extension cord and the furnace or generator may not be secure, leading to arcing and sparking, which can also cause a fire. Fourthly, the use of multiple extension cords to reach the furnace can create a tripping hazard and increase the risk of damage to the cords. Fifthly, the generator may not be properly grounded, increasing the risk of electrical shock. Sixthly, the generator may not be equipped with ground fault circuit interrupter, or GFCI, protection, which can help prevent electrical shock in wet or damp locations. Seventhly, the homeowner may not be aware of the proper procedures for operating a generator safely, such as ensuring adequate ventilation and avoiding backfeeding. These are just some of the potential hazards associated with using a cord and plug connection for a furnace. By investing in a properly installed transfer switch, you can eliminate these hazards and ensure the safe and reliable operation of your furnace during a power outage. Let's delve into the technical aspects of transfer switches and their operation. A transfer switch is essentially a double pole, double throw, or DP/DT switch that allows you to switch between two different power sources, utility power and generator power. The switch has three positions: utility, off, and generator. In the utility position, the furnace is powered by the utility grid. In the off position, the furnace is disconnected from both the utility grid and the generator. In the generator position, the furnace is powered by the generator. When utility power is lost, the transfer switch is manually or automatically switched to the generator position. This disconnects the furnace from the utility grid and connects it to the generator. The generator then provides power to the furnace, allowing it to operate normally. When utility power is restored, the transfer switch is switched back to the utility position. This disconnects the furnace from the generator and reconnects it to the utility grid. The generator is then shut down. Transfer switches are available in a variety of sizes and configurations. The size of the transfer switch must be matched to the electrical load of the furnace. The configuration of the transfer switch will depend on the type of generator being used and the specific needs of the installation. Some transfer switches are designed for use with portable generators, while others are designed for use with permanently installed generators. Some transfer switches also include additional features, such as surge protection and load shedding. Surge protection helps protect the furnace from voltage spikes that can damage electrical components. Load shedding allows you to prioritize which appliances are powered by the generator during a power outage. This can help prevent the generator from being overloaded. When selecting a transfer switch, it is important to consider the specific needs of the installation and choose a transfer switch that is appropriately sized and configured. It is also important to choose a transfer switch that is manufactured by a reputable company and is certified by a recognized testing laboratory, such as Underwriters Laboratories or UL. Furthermore, consider the importance of regular maintenance for both the generator and the transfer switch. Generators require periodic maintenance, such as oil changes, filter replacements, and spark plug replacements to ensure proper operation. Transfer switches should also be inspected periodically to ensure that all connections are tight and that the switch is operating correctly. Following a regular maintenance schedule will help prolong the life of the generator and transfer switch and ensure that they are ready to operate when needed. Additionally, consider the benefits of installing a whole-house surge protector in addition to the surge protection that may be included in the transfer switch. A whole-house surge protector provides an additional layer of protection against voltage spikes that can damage sensitive electronic equipment. Voltage spikes can occur due to lightning strikes, utility switching, or other electrical disturbances. A whole-house surge protector can help prevent damage to the furnace, as well as other appliances and electronic devices in the home. Finally, consider the importance of educating all members of the household in the proper operation of the generator and transfer switch. Everyone who may need to operate the generator and transfer switch during a power outage should be familiar with the procedures for starting the generator, switching the transfer switch, and shutting down the generator. This will help ensure that the generator and transfer switch are operated safely and correctly. Let's also consider the role of local building codes and permitting requirements. Before installing a transfer switch, it is important to check with the local building department to determine if a permit is required. In many jurisdictions, a permit is required for any electrical work, including the installation of a transfer switch. The building department may also have specific requirements for the installation of transfer switches, such as requiring that the transfer switch be installed by a licensed electrician and that the installation be inspected by a building inspector. Obtaining a permit and complying with local building codes will help ensure that the installation is safe and compliant with all applicable regulations. Additionally, consider the potential for future expansion when selecting a transfer switch. If you anticipate adding more appliances or equipment to the generator in the future, it is important to choose a transfer switch that is large enough to accommodate the additional load. It may be more cost-effective to install a larger transfer switch initially than to have to replace it later with a larger model. Furthermore, consider the environmental impact of using a generator. Generators produce exhaust fumes that can be harmful to the environment and to human health. It is important to operate the generator in a well-ventilated area and to avoid prolonged exposure to exhaust fumes. Additionally, consider using a generator that is certified to meet emissions standards. These generators are designed to produce fewer emissions than older models. In conclusion, connecting a furnace to a generator with a cord and plug is a violation of the NEC and poses significant safety risks. A transfer switch is the recommended solution for powering a furnace with a generator during a power outage. A transfer switch provides a safe and reliable power source for essential appliances and ensures code compliance. When installing a transfer switch, it is important to follow the manufacturer's instructions and all applicable codes. It is also important to consult with a qualified electrician to ensure safety and compliance with electrical standards. By taking these precautions, you can ensure the safe and reliable operation of your furnace during a power outage and protect your home and family from electrical hazards.